Hey guys, it's Miss Johnson here, and I'm here to bring us our video for the 7-4 notes, talking about nth roots today. How do we find nth roots? What are nth roots? And what do we do with them? Our example up at the top says the volume of a sphere can be found using the formula V is equal to 4/3 pi r cubed. We just looked at this formula when we were doing all that MCA prep stuff a couple weeks ago. It says find the radius of the sphere if the volume is 225 centimeters cubed. So what I need to do is I need to take that volume that I know and plug it in for V. So that gives me 225 is equal to 4/3 times pi r cubed. Okay, now I'm trying to find r. That's my goal. Since I want r, I need to get rid of the 4/3, get rid of the pi, and somehow get rid of that power of 3. The 4/3 and the pi are pretty easy. We know how to do that. To get rid of 4/3, I need to multiply by the reciprocal on both sides. Because what that's going to do is I have 4 divided by 4, which cancels, 3 divided by 3, which cancels, and that cancels that out. On the left-hand side, when I simplify, 3/4 times 225 is 168.75. So now I'm just down to pi r to the third, and the next thing I need to get rid of is the pi. So I'm going to divide both sides by pi, since pi is being multiplied. So that makes those go away. And when we plug that into our calculator, 168.75 divided by pi is approximately 53.7. Now the cube of r, radius cubed. To get rid of that cube, we talked a little bit about this in chapter 6. We need to take what's called the cube root. It's not square root. There's a little 3 in front of that radical sign. So I'm taking the cube root of r, and we looked at in our calculators on where to find that. Depending on which calculator you're using, it's in a bunch of different places, but we can use our calculators to find this. If I plug that into my calculator, the cube root of 53.7 is about 3.8. Okay, so I know that my radius is about 3.8 centimeters. Okay, so talking about nth roots there. Now, let's take a look at these powers and what they mean if I'm finding their roots. Now, the power of 2, that one's pretty simple. We're very familiar with that. If I have a squared is equal to 16, that means I'm taking the square root of 16, which is going to equal 4. So 4 is my root. Okay, the square root of 16 is 4 is how that is read. Again, very familiar with that. We've done square roots a lot. When I have a negative underneath that radical, we all know that that gives us an imaginary result. Now, for our purposes, we're not going to be using those imaginary numbers today. We're only going to be looking for real solutions. So that might be a note to write down. Only look for real solutions. So if I had the square root of negative 16, I have no real solutions there, so I'm going to abbreviate that NRS, but that's what I'm looking at, no real solutions. Now, let's take a look at a to the third. If I have a to the third is equaling 27, that means I need to take the cube root of 27. And when I take the cube root of 27, I end up getting 3. Okay, and again, that's read the cube root of 27 is 3. You've heard me say that a couple times, but that's what that looks like. Now, when I have a cube root of a negative number, I actually do get a root there. There is a real solution. The cube root of negative 27 is negative 3. And the reason for that is that negative 3 times negative 3 times negative 3 is in fact negative 27. That is possible to do. So the cube root of negative 27 has a real solution. Let's go on to the fourth root. If I'm looking at a to the fourth equaling 81, that means I have to take the fourth root of 81. And when I plug that into my calculator, the fourth root of 81 ends up being 3. Okay, and again, that's read. The fourth root of 81 is 3. When I go back and try to plug in the fourth root of negative 81, this one is going to take me back to no real solution. No possible real solutions underneath that radical because I can't multiply 4 negatives together and get a negative result. If I multiply 4 negatives together, I get a positive result. So no real solution there. The fifth root, if I'm looking at a to the fifth equaling 32, that means I have the fifth root of 32, is equal to 2 when I plug that into my calculator. And again, that's read the fifth root of 32 is 2. The fifth root of negative 32, if I plop a negative underneath that radical, is possible. This ends up being negative 2. And again, because negative 2, negative 2, negative 2, negative 2, and negative 2, 1, 2, 3, 4, 5 times multiplied together, these two would make a positive, those two would make a positive, that one would take it back to negative. So that does give me negative 32. The fifth root is possible when I have a negative number, the fifth root of a negative number. And then if we just look at the generic symbol, the generic terms there, a to the nth power means I'm taking the nth power of, or the nth root of b, and that's going to give me an answer of a. Okay, now let's talk about a general pattern for these negative roots here. Hopefully you're noticing something between my even roots and my odd roots. When I have the square root, meaning there's a little 2 there, and when I had the fourth root, I had no real solution. But when I had the third root and the fifth root, I had a solution. There's no coincidence there. That is an actual pattern. So if I'm taking the nth root of an odd, I should say if I'm taking an odd root, so if n is odd, then a real solution exists. Okay, but if n is even, then no real solution exists, or no root, I could say. Okay, and just so you know, just so we kind of are all on the same page, when we look at these little numbers here, the 5, the 4, the 3, and the 2, those are called the index. So when I say it as an index of 3, that's what I'm talking about there. Let's take a look at some examples. If I take a look at number 1, I have the square root of 25 x to the 4th. When there's no index written, by the way, it's what we're all used to. It's an index of 2, the square root. So if I break that apart, that means I have the square root of 5 times 5, just breaking down that 25 into 5 times 5, and I have 4 x's, so x, 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 and x. Now, I know that if I'm looking at the square root of 25 or the square root of 5 times 5 and I have an index of 2, that index of 2 tells me that I'm looking for any pairs of 2 things that I have underneath the radical. So I have a pair of 5s, I have a pair of x's, I have another pair of x's. All of those things are going to come outside of the radical. The square root of 25 is going to be 5. The square root of 2 x's is going to give me an x, and the square root of another pair of x's is going to give me an x. So every 2 underneath made 1 outside. 2 underneath, 1 outside, 2 underneath, 1 outside. So I end up with 5x squared. Okay, now most of us are very familiar with finding the square root of numbers, but it's when we get into other roots that it's a little different. Now let's take a look at number 2. So I'm taking this whole thing and raising it to the 8th power. I'm still at an index of 2 there, so I still want to look for pairs. Well, if I have 8 of those, that means I have 4 pairs. Okay, I have 4 pairs of that y squared plus 2. So that means I can take 4 outside. Okay, I still have that negative out front. That's just out there hanging out by itself. But if I have 8 underneath, I'm going to take 4 pairs outside, which means I have y squared plus 2 raised to the 4th power. Now, I used all 8 of those. I have none left over. So that means there's nothing else left underneath the radical, and that's my simplified answer. Let's take a look at number 3. Now I'm looking at the 5th root of a number. Okay, 5th root of a number. So again, if I think about breaking down that radical, I have the square root of 32. That's the same thing as 8 times 4. That's the same thing as 4 times 2. That's 2 times 2. We all remember doing prime factorization. This just gives me how many factors I have underneath. We'll take a look. There's 1, 2, 3, 4, 5. Okay, I have 5 factors of 2. Since there's 5 factors of 2 and I'm looking at the 5th root, I need a group of 5 to pull it outside. So that means this group of 5 underneath the radical is going to make 1, 2 outside of the radical. If I think about the x's, I have 15. So if I have 15 x's underneath and I'm looking for groups of 5, that means I can take 15, divide by 5, and I have 3. So there's 3 x's, or x to the third power, outside of the radical. Same thing with the y's. If I take a look at y to the 20th power, I'm looking for groups of 5, so I can take 20 divided by 5 and I get 4. So y to the 4th power. And also, neither of these had remainders. 15 divided by 5 is exactly 3 with nothing left over. 20 divided by 5 is exactly 4 with nothing left over. So I've now canceled everything underneath the radical. My radical is gone, and here's my simplified version. Last example that we'll talk about in our video today, in number 4, easy one. This is the square root of a negative number. And if we're only looking at positive roots, or I should say real roots, we're only looking at real roots, I have no real root here, so no real solution. Okay, that's going to take us to the end of our video for today. Thanks for watching. Don't forget to pop back to Schoology and take care of that quiz. Have a great night, and I'll see you tomorrow.